Okay, welcome back, participants, in the second session of today. Here we have with us Dr. Suman Dev, who is the professor in CSE department of NIT Agartala. Dr. Suman Dev is also the head of the CSE department. He is also the associate dean or dean academic and chairman of Institute Innovation Council and Startup. His primary research interest spans the area of visual inference with artificial intelligence, robot vision, human-computer interaction, and education technologies. This is blended with critical issues of augmented face-to-face interaction, innovation in teaching, learning methods is a continuous endeavor of his work. He is also the faculty in charge of HCI and AI lab of NIT Agartala. He leads a vibrant research group named Visual Intelligence and Machine Learning at NIT Agartala. His team has developed various low-cost innovation in access control, humanoid robot skeletal movement analysis, ROV, and AGB path plan, SLAM visualization, etc. He is passionately involved in the design of computer-mediated learning environments for transforming a traditional classroom with interactive scaffold. He has initiated artificial intelligence specialization under MTech curriculum and continuing as the faculty coordinator of the same. He is well known for his technical demonstration, prototyping, and motivation to large group of successful students. Apart from academic activities, he is also better known as designer of both NIT Agartala and IIIT Agartala logo. A person instrumental in achieving Guinness World Record accomplished with the title of the most people folding origami sculptures simultaneously in 895 on 24th January 2007. His paper selected among top 3 during Indian International Science Festival at National Physical Laboratory, New Delhi. He has won several best papers during international conferences like India, ERCICSCNC, Mind 2021, and ICCA 2021, etc. His guided science model won first prize at the state level science fair multiple times. He has authored more than 11 edited volumes and book chapters with more than 80 research articles published in significant journals and conference proceedings. He has been involved in organizing more than 37 national FDP workshops, including 3 prestigious international conferences, national level hackathon. He has also received multiple research and consultancy grants that includes prestigious TST in project, AIC grant amounting to 10 crores. So that's all about the introduction of Professor Dr. Suman Dev. So now I'll hand over the presentation to start. Sir, you can start your session.
Thank you so much for this introduction, and also I'm feeling privileged to be with you. I hope I'm audible.
Yes, sir, you're audible.
Okay.
You can start the session.
Thank you, everyone. So is it visible to you all, the screen? Can you please confirm? Is the screen visible?
Yes, sir, the screen is visible.
Okay. Thank you so much for inviting me for this interactive session on national level FDP. And I express my cordial gratitude that to be with you for certain moment will be enhancing my individual experience, and also we will be having a lot of interactive systems, not on a conventional one-way topic. That is, I'm discussing the matters not as an expert, but I'm discussing my experience with you, so we can have a mutual understanding about the concept, which can be for all of us a new avenue. That's why the title is Avenues of Visual Intelligence. Many cases we only find that artificial intelligence are comprising of different subdomains. Visual intelligence is one of the most dominating part. And it is nowadays said that if we converge most of the sensors and just create a very good processing part and have a proper visual information, maybe as a human, we don't have too much of sensors. We have a very nice processing system, that is our brain, and inputs through visual systems give us a lot of input. Now, today I will try to express some of the ideas on visual intelligence. As it has been already expressed, that I work mostly into human-computer interaction, including these visual sensors. So I thought, why not to just include some special areas into that and perception on small, that is a single board based computers, that when we do visual processing on large computers, high grade computers, GPU based computers, that is almost a very natural part for any researcher. I guess most of the faculty members and the audience, they are expert in various domains of such type of areas with high computation. But when you want to do with low computation resources, it becomes a different concept, different challenge, and different area of expertise and application. Now, a fundamental of computer visions are almost same for every cases. So I thought to discuss on these few topic and how we are using depth vision and different kinds of LiDAR systems for robot vision, that we'll also try to discuss. Now, scope of relevant application is the major part, where I thought that during this given time, we can have some understanding that how we can explore these possibilities. Assuming that some of you are very expert in the domain, and also assuming that some of the person may not be worked directly into the area, I thought that explain the vision first from a human perspective. Now think about you and me. We are looking at this moment. I'm sitting at Agartala. You are sitting in other part of the country, and your perception about the discussion, the audiovisual representation, definitely is a very common matter. But apart from it, what you are identifying about myself on the screen, you are seeing my slide, also my view. I'm sure if you take it the human factor, not as a research factor, you can find out that right now I'm wearing a white shirt, so there are some background matters. So you are not just looking into me, you are also getting some perception about myself and some intuitive data and some concept about myself. It may include my age, it may include my other resources around me, even it may include my different kinds of correlation with your existing environment. But all those things comes up with some physics and physical representation like color and other matters. So if we talk about clearly computer vision, we talk about only color, pixel, etc. representation. And many of us are utilizing all those things for our different purpose. But the point here, if we see the images as a collection of pixels, or these signals are coming as a terms of pixels, so we cannot think beyond the meaning. So we can only process the pixel in a statistical manner or some kind of data manner. So that means this become more challenging the moment we want to add some meaning to it. The meaning doesn't mean an object identification. Meaning doesn't mean even that identification, some of the say types of the objects, etc. It is much deeper, and it coming with a semantic relation. Like for example, I had a consecutive FDPs and various other lecture session, and one very interesting experience I got. Right now, I'm showing you a pen on the screen. That means on camera, you can see I'm showing you a pen. Now, this is another sketch pen. And I'm asking you just straight question. So there's a marker or sketch pen, and there is a pen. All you know the usage. How this meta information is with you? Is this that the meta information is available or stored? Can we make that once I show it to the computer, that means the camera, it can show it is used for fine writing, it is used for only marking. That means those meta information, and what is the relation? Do they belong to the same class? Now, all those meta information can give a semantic relation of those objects. Yes, there are very big avenues of those semantic relation of objects. And also there is a precise avenue where we can find out that this pixel level analysis and the conventional systems are also important. As there is a limited time, and going too deep into certain extent is not possible. And I have seen other sessions had been some hands-on. So really, I find that you people are already got some knowledge, and there are very good speakers, very eminent speakers. They have definitely said the usage and different application part. So I thought, why not to discuss some larger part, that what are the tools available? What are the possible algorithms? which can give us these wings, and some case studies where you can find out it can be my own domain of work or my area of expansion. So these images are formed in terms of a matrix, all of us already know. And we know that this manipulation of those matrix data can create different kinds of filtered output or can create some kind of meaningful output or any kind of, say, we can say analysis of those pixels. Now, if we look into the property of pixels or property of images, that gives us multiple channels, like channels of color, and those pixels properties, like how much color variants are available, how many bit depths are available. So these are very common part when we go through any kind of image or distribution of those images for certain purpose. But today our main topic is computer vision in a different perspective, which is artificial intelligence. Now, the moment we talk about this artificial intelligence in terms of machine vision or computer vision, basically we want to mean human-like behaviors and mimicking human behavior for defining some of the scene. Deliberately, I have taken a very hazy photographs for this slide. Hope all of you can see the photograph on the screen. Now just take a pause of 10 seconds. Just don't go through the text and everything. Just think as a human. We all from different background, different purpose here in the FDP. Just look to the image and 10-second pause. Now think about the image. What you can derive or perceive from the image. Definitely first thing you are getting, there are few cars. More and more you are analyzing about the image, that means you are going granular information. Oh, it also seems as a farmhouse beside some river, and there are some that means hills far away. There is a fountain. That means you are processing the image from the given information, not just pixel. You are not going to the pixel level. Pixels are constructed here, constructing some kind of objects, and objects have been already perceived to you. So such type of intelligence or such type of ability or algorithmic approach to the machine vision or computer vision is already available. Now, more deeper analysis. Are those cars connected? There is a partial visibility of car. Can you see the brand of the car? Can you find out which country image it is? Can you find out which season of the part? So that means we are trying to go more and more kind of scene, what are the objects there, and also different meaning or correlation. So as a human, we are doing with an ambiguity and also a probability. That means we are not sure if I am saying this car is of that brand, but till partial data we can process. We are trying to make it. Now a machine can do it. That is the object, and that is the main manner. So I thought for my own sake, I just thought why not to discuss some of the early CV, that is computer vision matters, so that we can feel comfortable. Nowadays, we are having a lot of advanced tools, and early CV like early 2000, 2003, 4. So that time of period, it was a very early CV consideration. So how that time things used to work. Even we see smile shutters and etc. At certain point, it was very, very fascinating. But now it's very common. Even age identification, gender identification, common. People can now go very rapidly. But those challenging applications comes more in is that means advanced level. This citation, I'm very happy to share with you. That means it was fascinating to me at the early time that a National Geographic front page cover was with an Afghan girl, and the girl look was very that means attractive in that sense, as a from photography point, from looks point, around the world it was an icon. And after so many years, around 25 years, the question came up, can this girl be identified today? Because it was an unknown refugee girl. If you go to Wikipedia, you can get the whole story. So it was thought that how the girl can be identified, because the photographer who took the photograph, it was a refugee camp, a photographer. I have to just hear me.
Yes.
Can you hear me? Someone please confirm. Am I audible?
Yes, sir, you are audible.
Okay, okay. There had been some network disruption. My screen is also visible, no?
Yes, sir. Yes.
Okay, okay. Sorry for the interruption. Actually, this famous citation, all you can see that is what I'm trying to show here. That means it is not only just image processing and etc. There is a thematic requirement also for computer vision. That thematic requirements forensic and even different kinds of reconstruction of the images. So these examples gives us a motive that computer graphics had been there for a long time, where we work from model to image. That means we convert some model to image and create a reconstruction of image. It may be synthetic image. And for photography, that means an image to image. And if you see that the moment we talk about computer vision, it is image to models. At any moment, if you find any problem, please stop me and just let me correct those things, any communication or any kind of visual matters, because I'm not getting the feedback. Okay. So computer vision is today's discussion, and it is also intelligent computer vision. So our primary objective is image to models. That means right now you're looking at me, it's an image. The moment you get some information and you take some kind of pattern and etc., and you're trying to reconstruct the image to models. That means the meaning you are trying to derive. So this derivation or this model creation is our objective. Now, if we want to achieve all those things, that means the kind of processing required is huge. So quickly, if we go through, what are the requirements of those intelligence? Safety, health, every cases. If mammography is analyzed by human, there may be some missed out information. If there is a multiple set of mammography, those mammography can be combined and can be a joint relation. So those MRI or mammography or whatever the images are there can be given to some kind of pattern matching or identification. Similarly, surveillance, similarly, home automation, etc. This is one example. In our lab, we have developed just a simple tool that can we create some kind of UI with existing software, where the existing software like game. Excuse me, please. Am I audible and visible, or everything is fine?
Yes, sir. Yes. Sir, you are audible.
Perfect, perfect. Please, at any moment, if you face any disruption, please let me know. Okay, so in our lab, we try to develop a system that can a natural gesture, like a person's movement, etc., can be utilized for existing games or existing any kind of system. So it was always a very catch point that if you take your existing system with software level and whatever your other limbs and combine them, there some challenging matter comes. Like we want to use our hand for acceleration and etc. part. Similarly comes accessibility. In different kinds of places, accessibility also comes into the picture. As we are all from academic background, all of you are just focused not on the stories. You are focused on scientific evidences and scientific relation. So this is a combination of different fields, which is now very much required for vision-based AI or computer vision intelligence. Now you cannot ignore one part from the other, and you cannot leave one part from the other if you want to make a complete information. For example, here you can see that robot vision comes very later, but it has a lot of dependency. Like signal processing as a camera is required, physics, just like optics, imaging, different kinds of smart camera, and then mathematics for statistics, geometry optimization, then cognitive vision like machine learning, and computer intelligence like artificial intelligence. And there is a major areas like computer vision, machine vision, and image processing. Sometimes we mix them all. Sometimes we cannot find out there is a fine overlap. And obviously, there is a thing called neurobiology or biological vision. I hope all of you will be agree that unless we put all them on a single page, there should not be a very proper understanding in which area I'm going to work. what to leave and where to put more focus. And if we combine them, maybe machine vision, robot vision, or control robotics may come into picture. So we generally work into computer vision and machine vision along with image processing with little bit of overlap. Now, how computer vision can be different from machine vision? That is a legitimate question. So in course of discussion, we will be coming to that. So if we just move the traditional image processing part, that is a necessary part of computer vision and machine vision. And that's why our application of vision system requires a proper structure or an understanding. So definite part comes with image acquisition. After the image acquisition is done, then there are natural pre-processing, then extract the features and detection or segmentation, recognition or interpretation. Now look to the whole structure. So we are having a problem domain. Unless the problem domain is defined, all image processing or image intelligence will not work. I want to detect certain objects. I have to focus on that problem domain, because depending on that, my image acquisition will work. Whether it is a depth camera, whether it's a thermal camera, whether it is a night vision camera, lot of systems can work in a separate way in their separate domains. But if you combine them and put the expectation in one, it may be difficult. So that's why you require a processing part also. And that goes to the segmentation, pre-processing, then recognition, interpretation, and result comes. So generally there are two types of processing. One is low-level processing, one is high-level processing. Again, the image intelligence comes in terms of high-level processing. But the traditional other methods like pre-processing, traditional algorithms for image processing are a supportive part. And all of them has bidirectional, that means communication with knowledge base. That knowledge base works with a semantic knowledge. Sometimes that knowledge base works with previous experience, the patterns, annotation, etc. So roughly this is a structure. This structure varies greatly, but for domain to domain, it is a bare or simple structure, which works as a CV, basic architecture of working. So these are very common words and common concept, which all of us bear whenever it comes about the image recognition. But I ask this question to myself, what about this computer recognition and how this computer recognition is defined? Because if we say a recognition by computer on an image, that means whether it is a car, whether it is a human. So is this just like the human processing, or like human, we are doing a less processing? That's why we have to go through a pipeline again, steps in image recognition. So this pipeline is greatly a level pipeline or a general level pipeline. More and more we talk about general, things becomes ambiguous and vague. So data acquisition and sensing is again a general term. Data pre-processing, general term. Feature extraction, general term. Model learning estimation, general term. Classification, similar way. And post-processing, similar way. But you see, this pipeline can be expanded based on the objective and based on the requirement. Now, if we go further, this recognition, how it takes place. Deliberately, I have taken this picture from just a search on this internet and took up a picture which any person can search and get. Reason, I have shown some of our lab works. Why lab works not shown? There is a rationale for that. You know, generally any new thing, whenever a researcher learns, they generally search on Google and find out what are the available resources, also consult the other published work and review matters. In most of the cases, we find out the preconceived matters is there, which helps us to create an objective. But if the preconceived matters are there, then how the objective can be uplifted? Look to these photographs. These photographs having cat, one dog, and one hare or a rabbit. Now there is a very close, that means facial and body structure and fur color among these three species. If I ask, are you sure the first one is cat or dog? If we take the third photograph, you will be surprised that yes, as a human also we are confused. But the moment there is a systematic photograph, from the first photograph you can see it's a cat. That's why you are feeling you are confident. But see the last photograph when it is overlapped. How do you know that they are cat or they are not all cat, they are all dog? Because it is converged, overlapped, and ambiguity is there, it is difficult for even to a human to identify. That's why your region of interest or segmentation, but then it is helping you to classify in which group it belongs. So these are some inspiring computer vision history. I'm not going into detail, but only one inspiring part that 1960 or those period, even 50, computer vision had been started. So it's not a new matter. So what is the new part at this moment? It is the intelligence, or how we can make it further. So that's why there are some research domain which is very popular, and there are some even going further. Now there is a trend of futuristic CV. That is what we have been doing for last 10 years. In next 10 years, we may not do the same thing. I hope all of you will be appreciating one part. The moment you look to a photograph, the moment you look to any kind of information, you have your own style of perception. It's not necessarily that you'll be matching with me, but if such type of bifurcation or individuality goes on, we cannot come down to a conclusion. So that's why again I'm giving you example that I'm having some object in my hand right now. Do you have ambiguity about this object? Do you have multiple opinion about the object? By and large, it will be not. All of you are looking to this and saying X. The X is a remote. Now this remote is a common and a common conscious you have got. It is not, there is no ambiguity about the matter. That means whenever we are talking about as a human opinion, we also know their subjective preference. We also know our previous experience. We also know how I am perceiving that my vision, that my other clarity, etc. I hope all you agree. So every time before starting a topic or matter, we always try to get how the human is working, how the human level process are going on. That's why we find out that some basic definition required to be very clear at the initial part. So how do we recognize objects? How do we identify objects? And most importantly, how the system can be created. A system can identify the objects or it can recognize the objects. So there are two questions. And where is the object? So I'm not going to the complex matters, just two simple matters. Right now on the screen, this is a window. You are finding different kinds of information available, including myself. Let's take it simple thing more simpler. As a human, how do I ask questions? This is my objective at this moment to learn. What is the object in the image? So what is the object in the image? The answer required. Where is the object? Now there is no visuals on the screen you can find out. As I mentioned several times that I know many of you are very expert into this domain. So try to understand the question. At this moment, what is your goal to find out? Yes, I'm showing you the object. You know what is the object. This is a question. But this is not available on the screen. I'm asking you what is the object. Can you answer? No. So these two questions required to be given answer by any system. That's why I thought let's discuss these matters. And this is a primary requirement of any systematic research into object detection, object recognition also. That is, how do we perceive the matter first? So we are giving some input, that is an image input, and we expect some output like the position, label, and etc. Now label means, what is this? That is, if there is a label, the label means machine can say this is a remote. The label says, okay, it is something else, some kind of other calculator, etc. So if we see object recognition, it always deals with which object is depicted in the image, the input and output. And next question, what is object detection? Detection means I know there is a remote. I know I'm searching for a remote. Where is the remote? Where is the remote? You know it's remote. Where is the remote? That means on the screen, you are not finding it with a label of left. You are finding with a position, coordinate position. So on the screen, right now your subject is on the small window where you can see me. A small window where you can find out things are moving. So you imagine yourself as a computer. Your objective is to find out where it is. That means what you will be returning? Some coordinates, some pixel points, some bounding box, some leveled area. So where is the object in the image? Input, a clear image, and output, a position. That means bounding box. I hope this slide is very much clear to you. So in this way, if we think of, I hope the simpler things becomes more simple. As a faculty, as a researcher, we always find ourselves sometimes dominated with a complex object. Complex object, definitely it's our goal to solve. But when we interact, we must have a very clear idea that what is the things we are going to discuss. Allow me to proceed further. From now onward, there will be around 20 or 30 slides I may, as a layman, will be presenting the slides to you, just as if I am asking the question to myself that I want to work on object detection, how I can work. I don't want the deeper knowledge. I want a surface level knowledge. I want to work in object detection. What are the things I should do? So that means I got the definition of object detection. And now I got my target also. What is the input? A camera input. Camera is there available, fine. What the next thing I'm going to do? Next thing means I need a sample through which I can satisfy myself that what is going to happen. Yes, there will be an image. On the image, what are the items available, the entities available? Like here, a horse, human, and you can observe at the back side also there are two human. Maybe if you go more drill down there, you can find out more horse, dog, etc. But as a human also, we don't go deeper, or there are some perspective. Beyond that, even it is not possible for myself also to understand as a human. So that's some few things we understood. On the right hand side, deliberately I have kept here a partial photograph. Look here, a dog is visible. Computer is saying there is a cat. Where is the cat? If it was not labeled as a human, could you find out a cat there? No. That means as a human also, we go through some systematic steps and groupings and labels. So it is our identification. So these are almost all of us that our precision matters, average recall, etc. But how to identify objects? There must be some algorithms. So there are a lot of techniques. One technique is two-step object detection. Now, what is two-step object detection? I just written here a few lines, and there is a diagram. In diagram, there is systematic layers, like one image, then some convolution layers, features mapping, region proposal network, proposal, classification, so ROI pooling, etc. You may ask me those questions. What are those? I need a separate lecture session. So at this moment, as I told, I'll be keeping a lot of such data just to keep myself as a layman. What are the tools available? So basic algorithms for two-step object detections are some names like fast RCNN, faster RCNN, histogram of oriented gradients, HOZ, region-based convolutional neural network, region-based fully convolutional neural network. So many are there. So these are some of the names. Quickly, I'll go through so that I can enter to a case study. So we first have seen two-step object detection. There is another called one-step object detection. My slides and my whole assembly of the discussion is just like a flow, or you can say, and a simple note. Out of the note, which is your area of interest, which you find out important, you can go back and go to the detail of the matters. So there will be too much of information. When I was preparing the information, I was thinking you will be burdened, that means you'll be bored with so many information. But the next moment I thought that every resource person, all other people are maybe saying you the in-depth of other things. But can I take a different part that combine all of them and present before you so that you can correlate what is your area, what is your area of interest, how the experts discussion can be connected to your work. So in one-step detection, there are different kinds of methods like YOLO is also having multiple versions, etc. Now this two-step and one-step, YOLO full form is you only loop once and then you find out what are your desired region of interest and find out with solid output or a decision. Now, if you see all those things, algorithms and the matters, they must have an advantage, disadvantage, and there are some requirement of resources. Now, if you see those 1 or 2 line bullet points gives you a bird's eye view that how those algorithms are important for you for certain solution. So these solutions are having a structural representation. I'm roughly giving a structural representation and we'll be discussing for a few minutes. Like if one image is given to the algorithm, the image required to be analyzed from certain pixel points. And those pixel points may be kind of divided, and then the algorithmic approaches will find out a region of interest or a bounding box or a label that, okay, where are the face of dog? But while doing so, it's not sure that your algorithm will be 100% working. There may be flaws. There may be flaws in the input system. There may be flaws in the input algorithm itself. There may be flaws in terms of the quality of the component. That's why there may be some error also. So just to identify that all algorithms require proper execution, and even one algorithm may not be applicable to all the scenarios. So you have to be very serious and sincere about identification of the algorithm, which will be suitable for the purpose. There you can find out 3 square boxes. Those 3 square boxes are having false data. That means they are not showing any kind of dog space. So you can find out these algorithms way of solution, but we have to tune it according to our purpose. Different structure shows you a visual representation how one algorithm is different from the other algorithm. That means instantly it gives you an idea, say just, okay, these algorithms are different in structural view, steps view, but their purpose is same. Identify the object into an image. I also thought, why not to discuss advantage of different algorithms? That's why I noted down few advantage as well as some of the disadvantages. So these diagram and putting them in a summarized format gives us always a confidence to pick up a problem and pick up a solution suitable to that particular problem. So every algorithm has its representation with computational complexity as well as efficiency, high or low grade. So all those things require a very good structural representation, but they demand huge computation power, huge computation power. So is it possible that we can do it for some smaller computers like single board based computers like Jetson Nano, Raspberry Pi, where it will be used as an edge computer? And on the edge computer, we can deploy all those models. So all those models, whatever I'm just quickly showing you on the screen, it is just giving you an idea that multiple algorithms are there, but none of them are being tuned for smaller devices. Exactly, just you will take YOLO and run it on the small computers. It may not happen. You have to scale it down. So that is one of our area where we have worked on scale downing for different kinds of algorithms or all emitters. Different versions of YOLO are there, like this is version 1 architecture, then version 2 architecture, and then version 3 architecture, 4 and 5. So we worked up to version 5. So this is YOLO version 5. I don't know whether the latest version 6 is launched or not, but we worked up to version 5. Now these version 5 architectures are little bit of upgrades and modification. With that, we have come to a little and quick discussion that what are the algorithms available through which I can detect some objects. As those slides are having the information, you can go back and just search on Google and go deeper into the matter or discuss with your research team, and you can find out in that is identified manner. But my today's whole focus is on one topic, is image intelligence. That means we are not talking about image processing and object detection, etc. We want image intelligence. So rather than just saying about image intelligence, I have taken one example from military application and thought to discuss a military application from a ground level. So in a military application, there are a lot of image processing and time-based image exploration and identification is required. So there is a situation that image intelligence to explore what are from the visual photography, infrared, laser, we can derive to a conclusion. So I'll around in 10 slides, I'll explain a scenario. So you can find out the role of imagery is not to assist, it is also to make the system faster. So there is a commander in base station. He's focusing and protecting his combat power. Okay, a scenario is there. Now imagine he is getting some information from a drone, from a quadcopter, or from satellite. Now the commander is sitting in his room and he wants to find out certain scenario. Now a lot of options the person will be having, that what tools to pick up. So that tools, say as a developer, as a researcher, you will be providing. What is the primary requirement? It should be having low latency and accuracy, because only solution is not sufficient. You require low latency and accuracy. So whenever we talk about algorithm, many of our scholars and researchers, even the master students or BTech students, they come up with a rapid solution. Sir, this is done. But the moment we talk about the low latency and accuracy, it fails. Because if you do with a very high machine and the system is not affordable, then it is of no use. Affordable of money. Afford one, say NVIDIA high processing system in field. Can you take an NVIDIA system in a very rugged condition, mobile condition? May not be possible. So you have to always depend on low latency and high accuracy application. So whenever we are talking about these matters, we have to find out. I have collected this just to have a discussion with you. So what are the tools and purpose, how the image intelligence is coming into picture? So that's why this diagram, actually it's a general diagram from different application, like who is the end user of the intelligence, who are the process of interest. Many cases, whenever some person project their product, that is an image intelligence system, how do you select that yes, this intelligence system is required or not? That means an area of interest is important, purpose is important, then data processing is important. Like in our lab environment, I'll show some of the demo of our works, that we have to create a purpose, that what is the purpose I'm doing it. Then we go for those image and try and find out the intelligence matters. So once we make all those things combined together and the commander is still there, commander is trying to find out that how he can help his field person. So let us consider what are the tools he can use. He can use mini UAV, unmanned aerial vehicle. He can use some tactile UAV or satellite imagery. In every cases, the commander is going to get some images, either 2D or 3D. And what are the steps we can do as a researcher or the person? The first thing is tasking. That as you, the term of tasking I'm used, that this term, I'm not sure whether it is a very standard term or highly popular term among the researchers, but very frequently we use in our lab the term tasking. Let's create a task. So as I have given the example of a military company commander, so I'm considering the task for the commander is to find out some objects and priority with priority. So he can use several kinds of tools, like with the researcher, we will help him with matplotlib, seaborn, such kind of visualization tools. We can work some of the libraries, like Plotly, etc. Now, why I'm mentioning today at the beginning, I told you that I am saying to you not as an expert or just from the perspective of an expert. I'm saying from a common person problem solver's attitude, so that my knowledge is not stereotype. My knowledge can be an open, and we can find out a new problem and solve it or map it to that. So at this moment, what are the tools I'm available? I'm having, these are the tools as mentioned on the screen. Yes, with that, I'm going to help the commander. And then we can search any other professional software, like there is a professional software called Skywatch. It's a proprietary professional software used by combat, that means aerial view analysis. So this type of professional software is one way. Other, can we introduce our own research matters? So different kinds of map engines are there. Some of the examples are given. So imagine that you are or you are a solution maker or a researcher who want to give such an interface to the commander, army commander, and he requires to identify where is the hospital or where is the, say, some school. Now on the screen, can you find out in hospital school without any clue? That means you require strong processing, and on that strong processing, there are a lot of scalability option. So this story, whatever I'm trying to tell, it ends here with these two images. All the audience in this FDP take time. Find out a school and one hospital in this image, as you are the most intelligent human being. I think at least from a machine, you are millions times intelligent. Find out one hospital and a school. You will be saying what kind of question it is. It is completely ambiguous and vague question. If I give you time of say 2 hours, what resource you now additionally require? You can observe that, oh, by normal looking to the image, I am being most intelligent, high resolution processing, the highest computing technique, even better than NVIDIA processing system, my brain. I'm not able to find out the school. I'm not able to find out the hospital. Okay, anyway, by any chance, any person have found out the hospital and school, please let me know. For a long time, I'm only talking. I just want to see whether other audiences are still there or I'm the only person. So anyone, are you getting my core questions and are you getting my slides? Anyone, just please respond, even from the organizer side.
Actually, sir, participants are muted.
Okay, I understand. That's why just I want to take the sample. So I'm audible and visible perfectly?
Yes, yes.
Okay, thank you so much. Now see, my questions are common to all, that it is very difficult for you to identify even being human, not to speak of any algorithms and others. Now think of whatever the algorithms we have discussed, can they find out all those matters? That means we have to find out different kinds of exploration, exploitation, and different techniques. And that's the way through which we can find out that even if a system is given, we can find out some clustering, we can find out some property-based searching, we can find out some abstract searching, and then maybe coming to the conclusion, even it is not so easy. And then we require the dissemination. So these 5 steps exactly giving you a scenario or kind of situation where any one of with
Sir, your internet connection is not stable and we are not audible.
I hope there had been again a disruption. Please allow me to share my screen. Okay, so we were talking about the vision-based AI. Am I audible and visible?
Yes,
Yes,
sir.
Okay, thank you, please. Now, vision-based AI is really important part. Many of the researchers, as I told, that the trend in the trend in CV is now have converted to vision-based AI. Unmanned vehicle, unmanned robot, all those autonomous systems, they are now working more in on vision-based AI. So here also, different kinds of image recognition and processing comes with an objective. I'm quickly going through this. We are now focused in some of the tools. I have summarized several tools for you. Many of those tools you know, like OpenCV. OpenCV is one of the tools through which we can also work on vision-based AI. It is having some pros and cons. And then TensorFlow, it is also having some pros and cons. I'm not going line by line those discussion because as I mentioned in the slide, and slide will be shared with you, probably it will be no issue for you to go through. And such type of things, if you search on internet, you'll be getting a lot of resources. I'm not the only part just to mention those. And this CUDA processing. So quickly, if we go through, that means there are large options available. This is not the confined option. You can work in several areas. In our lab, we work in various areas and various of such topics, and different students work on different such type of tools. And the reason, that means I don't take up one tool only for everything. That depends on my objective, depends on the purpose. So all these tools gives us some advantage and also some limitation. Like Amazon recognition, it works mostly on face recognition, but you can also find out the community is not so bigger, and the development APIs are also subjective to very limited matter only. Now, Google Cloud Vision API, these are also very vast scikit image, etc. Now, I'm more interested, as I have given a very limited time, next 10-15 minutes, I'll discuss on some of the objective, what we approached to solve and what we have found out. Now, in our lab, we use a very simplified architecture that let's take the computation by a base station, which is a high computation power. And there should be a communication between the edge or the robots or the, that means field computers. So there will be a limited computation in the field system with field sensor and field actuator. And they will be having a local processing system, local decision making system. Over the communication module, they will be consulting to the base station if further clarification, further that means precision required. If we look here, okay, these are some. On screen, you can see different kinds of bare chassis. We worked on different geometrical chassis, different augmentation methods. They are all working on vision-based AI. This is an interactive system. This has been published also in the top conference Interact, where the interactive system computer and the living person can have, and with the objective and purpose. It is about oral health. How do you brush? Are you brushing properly? Computer can observe and computer give you suggestions, and it has been gamified. And once it has been gamified, now you play and brush, and with that your reflex get uplifted and gets changed. Now, this is not just a rule-based system that only you are killing some of the germs if you are properly brushing and you got some score. It also looks about your attention. It also looks about your that means kind of inclination towards cleaning your teeth, because you are cleaning your teeth assuming that you are cleaning virus. But the moment we do brush, do you see the virus? No. If you teach a person like small kids at your home or all the individual person, we have tested it on a school level. These whole photographs you are seeing, it's a school level field testing, where we have taken our system and asked the school students like class 7, 8 students that apply it and find out how it's enjoyable, how you are getting things. And what happened, that if you are given a brush and said, okay, brush, your objective is to clean the teeth. But whom you are cleaning? A small kid. When we all had been kid, we were trained for brushing in the morning when we were feeling sleepy, or we were trained in the evening or late night when we were again feeling sleepy. So we were not taking it as a sportive manner, but by the time our reflex of brushing got changed. So similarly, we can think of different augmented matter. Anyway, it's a different research. It is not pertinent at this moment. These are some vector generation. Like if the camera can see me, can the camera draw me? So this is just by a ball pen. We have used this computer numerical system. By ball pen, on a normal ball pen, it is placed on a A4 paper. And this computer numerical control system, just using ball pen, these H curves, can it make an image? Different other vectors are generated. That is generative vectors, not just raster. Can we create vectors the way humans do? This is a glimpse of the lab where we do work and our students also work. We have some humanoid robots also. This is an example of another AI-based computer vision, that when you are driving, we have taken a movie clip and fed to the computer, and the objective was scan from the movie clip. The movie clip was a very high-speed car. Can it identify the roadside sign? That means when you are driving, your dashboard is having a camera which can observe the surroundings. Can it find out what are the road sign available? Can it find out whether you have missed out some road sign? So that was the objective, even how far it is. We also work into an area called simultaneous localization and mappings, in short, SLAM. Now, this SLAM is having, you search on internet, I'm not going deep into that. This SLAM, we can create three-dimensional pictures, three-dimensional surroundings about the lab, and also give the information to the robot kinematics so that it can express how to move. We are having a 3D scanner in the lab. This 3D scanner can scan three-dimensional system. But this 3D scanner is different from the room scanner. We are having Intel RealSense 455D depth camera through which we can three-dimensionally create the whole environment. And then the robot can make its position and it can maneuver around the that means situation. These are also some of the photographic examples. These are examples only showing that how the robots can identify objects and then it can find out where is the path. We have a holonomic drive. This is a reference. This reference taken from Boston Dynamics. That means these areas are very interesting where the robots can explore. This is a very advanced example of SLAM. Can the robot equipped with the LiDAR can go to cave and map it? I have given the reference also, the name of the paper also given, how it can map the cave, three-dimensional mapping of the cave. Okay, IMU data and etc. Now those SLAM, simultaneous localization and mapping, we are using a smaller scale of SLAM, just RP LiDAR. Now these SLAM and LiDAR, they are also classified in multiple groups. Like what is the purpose? Two-dimensional scanning, three-dimensional scanning, topographical scanning, etc. And these visual SLAM, we are working with the fusion of sensors. In our lab, we are making multiple sensors fused, and those fusion of sensors are connected together for a decision. So this unmanned vehicle and autonomous vehicle is one of our objectives. This is one of handmade robot in our lab. This handmade robot, the purpose is to explore the floor, and just let me play the video. So you can see the three-dimensional view of this robot. This is very small in size. So I was focusing from the beginning a small in size. Can it compute? Can it take a large amount of data, high grade of visual data, and compute its differential drive movement? So you can see it's a very niche product, and companies also started. CUBot, a company is there. This CUBot has multiple products started by my students. And these handmade products, the objective is, can they find out in a low computation power identification of objects and various other desired conditions? So it's again in the same thing, you see the sensor has been replaced by a LiDAR. This is a LiDAR. This LiDAR gives it a blind view. That means a cross-sectional view. It cannot identify object. At this moment, it is not able to identify object. Now it can only identify the obstacle. Where is the obstacle? How far is the obstacle? And can just find out some path. But there is no meaning of the obstacle. It don't identify whether it's a chair, whether it's a table, whether it's a toy, etc. So it can only find out the obstacle and then can scan the way and go somewhere. So all those small matters gives a big leap. That means, yes, many of my PhD students are working into these visions, which we are equipping on some such type of small, that means robots. This is an advanced robot. Again, also it's a handmade robot in our lab. This is advanced in that sense, its computation power is larger because its volume is a bit high. This is also a holonomic drive, and this is also very precisely done and very high computation is there. So here it is not only looking to the obstacle, it is also looking to the meaning of the obstacle, whether it is a table, whether it is a chair, whether it is any kind of other objects. So it can find out all the things with its semantic meaning. Let me go further. So we get the visuals from those robots like this. On the screen, you can find out some visuals are there, 3D cloud mapping, then clustered information. And we also make the algorithms to cluster the components and then label them. And then we can find out the path around the 3D systems. This is again a very large robot which can create rangoli. It can create a large scale of rangoli on a surface. And it is also again a vector processing, not a raster processing. So it can create such type of figures in a very large scale, 5 meters by 5 meters, even 10 meters by 10 meters. Very large scale such type of figures can be drawn. So the purpose of showing you all the examples, that means whenever we talk about visual intelligence, basically we're talking about a semantic representation of the surrounding things. So object identification, object recognition is a general part, but rest of the things will be coming as our semantic representation. So meaningful conclusion can become. I was trying to continue the session till 3:30, but I'm today bound to conclude the session by 3, as I'm having a very important academic meeting and no way I could manage this next half an hour. But till I'll spend some time if you have any queries with you. And I don't know how much I'm able to just express myself to you, but at least my intention was not a conventional way of just giving the components to you, but at least some kind of thought-provoking idea among all of us. This is my research group, Visual Intelligence and Machine Learning. This group is highly focused into generative systems of graphics, like generative adversarial neural network. Also, we are highly focused in taking semantic relation among the objects surrounding to it. And I'm inviting you all, if you get any scope, come to our lab. And this interaction through the FDPs is definitely a good chance where we can just open up our mind and we can find out how we individually can be meaningful to each other. I feel knowledge is not confined into just one part or just one FDP. Knowledge is just spreaded everywhere. According to our research domain, according to our expertise, all of us are working. If any one of you are interested, we are having master's degree program here in artificial intelligence, also PhD program. Anytime you can visit here, and definitely I want to listen something from you. From my side, I really beg pardon that I'm concluding the session half an hour back. So please, the session is open for some of the interactive systems.
Yes, participants, if you want to ask any questions, you can please put in the chat box.
Okay, someone is asking for mail or phone number. On the screen, my mail, phone number, and website is given. You can just note it down. If required, we can have interaction. Any other questions? Any technical matters?
Participants, you have unmuted yourself. You can unmute now and ask your queries.
Good afternoon, sir.
Very good.
Sir, actually, in the daytime and nighttime, the object detection quality will be same or different?
Completely different. You know, we have another wing where we want to explore. We are exploring. 2 of my master students are working. That is the same algorithm will not work in the same situation of lighting, different situation of lighting. As you know, if you are introducing the intelligent system, that is some kind of machine learning or machine training system, it highly depends on your objective. That means whether you are taking it for daytime or nighttime. Okay, now it may come that you want your system should be robustly work for daytime and nighttime equally. So for that you require a middle level of understanding that how those threshold of image quality is getting changed. That's why sometimes some people incorporate histogram analysis and others by which the quality of the image is identified. There is another big problem. If as most of our robots are mobile robots, when they are having outdoor environment and from outdoor they are coming to the shaded lab environment, suddenly the camera exposure gets changed, and instantly the camera exposure is so down that image becomes black, and even the normal things are not also visible. That's why there is another scope that how robot vision can be expanded under low light condition. It is also very interesting, even PhD domain also, that low light condition image processing, because low light images mostly comes in black and white terms. If you take low light images and use infrared camera, they are completely black and white. And those black and white images processing are different from the color image processing. So that's why it is never the same case. And if you want to get more and more accurate things like CCTV surveillance footages, these CCTV surveillance footages, the daytime and nighttime largely varies. So these are also very interesting area of that means research. But in summary, they are not same. You cannot process equally efficient matter for day image and night image. I also want to have some feedback from the audience also, not only just question, the feedback also required. Like for any FDP or for any kind of lecture session, a feedback, qualitative and quantitative feedback is really important. That you have to say something, okay, sir, it was good, sir, it was bad, sir, it was fine. Because these feedbacks are important sometimes to scale up the matters from a presenter side also. Because my perspective may be different from your perspective. So what I am thinking that I'm doing something good may not be good to you. So feedbacks are really important. Anyway, Mr. M. Krishna have said a great session, sir. Thank you so much. Okay. I really want to thank the organizers for inviting me as well as for just for giving these opportunities to interact with you. Yeah, please. Some questions.
Sir, how artificial intelligence is related to machine learning? This robotics.
Nowadays, you know, even the researcher, faculty, and students all get confused for certain times. Even if you ask to a first-year students what you are doing, he will be telling machine learning, even knowing not knowing the fundamental matters. So I personally feel people should have a very clear distinction that over last decades, over last say 30 years or 20 years, things got evolutionary changes and different terms have come up. If we take soft computing, artificial intelligence, they had been the classical figure of the human-like behavior or human-like processing. Nowadays, a specialized area comes like machine learning. So machine learning, you can consider as a subset of artificial intelligence or soft computing. So in case of machine learning, we don't go by just rule-based system. We go by patterns. So how human do process? Human don't process by just very precise numerical data. Human process, but in earlier days, maybe 10 years back in artificial intelligence classes, mostly we talked about the say first order predicate logic, then prologue programming systems, uncertainty, probability, etc., Bayesian network, etc. But they are the classical rule-based systems. But what happens nowadays, we more and more are moving towards the pattern analysis. Look at this moment, you are not looking to me as my weight, height, etc. You are identifying the pattern, and from the pattern, even someone is not telling my gender, you can know it's a male. It's a middle-aged male person. If I show you this pen, have you seen this pen earlier? Never. This particular piece of pen you have never seen earlier. But from the pattern, you can find out, okay, the properties looks like a pen. That means it's a pen. So this is machine learning. What happens in machine learning? We make the machine to identify the pattern by and large. There are also a lot of classification, and identifying the pattern, the machine can next time find out that where is the similar thing. I want to request everyone, visit one site lobe.ai, and you can identify the machine learning matters very interesting way. So these are distinct matters. They have different objective and they are not similar. Artificial intelligence is a superset and machine learning you can consider a subset. Okay, if there is no other question, I will request and I'll just ask for your permission that whether we can conclude this session and I can go for the next part.
Yes, sir. Thank you, sir. It was really a very informative session and very nicely presented. And I think the participants have gained a lot of insights into this artificial intelligence and machine learning from your session. Now, I request Dr. Pradyuman Ranjan Ghosh. Please participants mute yourselves. Okay, now I request Dr. Pradyuman Ranjan Ghosh to propose the vote of thanks.
Thank you, ma'am. Good afternoon, everyone. On behalf of Bharat Institute of Engineering and Technology, Hyderabad, I would like to extend our heartfelt gratitude to the esteemed resource person, Dr. Suman Dev, who is an assistant professor of CSC department at NIT Agartala, for enlightening us with the knowledgeable discussion on avenues of visual intelligence and machine learning. We also thank our honorable chairman, sir, for providing us with the infrastructure and facilities, as well as giving us continuous encouragement for holding this fruitful discussion. We would also extend our thanks to our fellow coordinators who have set up this event, and sincere thanks to all the participants who have made this event a memorable one. We look forward to another successful session. See you tomorrow. Till then, goodbye. And once again, thank you, Dr. Suman Dev, for this wonderful presentation. Thank you.
Thank you so much. Thank you. Thank you, everyone.
Thank you, sir. Thank you for your precious time.
Thank you.
Participants, now please wait for the feedback link. It will be pasted in the chat box. So it will be active for only 1 hour today. So all of you just fill the feedback form as well as the quiz and for your attendance of today's session.